Hello and welcome everyone to a new video series. Again, this video series is intended for the people who are planning to go for API ICP examinations or the people who are working in asset integrity. So, in this series, we are going to talk about API 578, which is a recommended document or a document that gives us guideline for material verification programs, which are to be kept in place by the owner or user of asset. Either it is going to verify the materials for existing components, or you can obviously verify or the materials that are used in construction for your newer components. Now, why this is important? Because see, up till now we understand that we have seen various kinds of damage mechanisms that can be possible in the refinery operations. Now, in most cases, we have also seen that some materials are going to be subjected to some kind of damage, and some other material might be resistant to that kind of damage but may be susceptible to some other kind of damage. Okay, so depending on what kind of service your part is going to have, what is the service condition, what is the service temperature, what is the process changes that are happening in your system, accordingly a material needs to be selected. So let's take an example. So let's imagine you require a stainless steel which is going to be 316L. L means low carbon. So if you have a specification that calls out for a stainless steel 316 lower carbon grade, but instead of receiving something which is of a lower carbon grade, you receive 316H, which is higher carbon. In that case, visually you will see no difference. Okay. Obviously, you can do some laboratory test, you can certainly do some destructive test on a component, but then again, the destructive test will not tell you everything about the component, because at the end of the day, you just take a sample out of it. So, depending on how critical the equipment is, we can at least take some samples out of that and we can do destructive test. But destructive test will tell me about mechanical properties of the material. It will tell me what is the tensile strength, what is the bend stress, what was ductility, what is hardenability. All of these things can be identified by some practicals. But what is the composition of the material? That is a different ballgame together, because in that case, you will require some chemical analysis tools that are going to verify what kind of elements you have in your alloy. That means we were talking about stainless steel. So stainless steel will have chromium, nickel, iron, carbon, all of these things at a certain percentage. Let's imagine I require chromium to be 55%. So I might be using some chemical analysis method to identify that how much chromium is present here. Okay. So now both of these things are done. We have checked the mechanical properties of a material and we have also checked the composition of the material, and if both of these things are as per the requirement or as per the specification, or in some cases it is as per the requirements given in ASME section 2, then we can certainly accept it. Okay, because what we have established is that mechanical properties are good, chemical properties are what was desired. The material test certificate also verifies all this. We are getting the same results on the practical scale as well. So both of these things are correlating so that we can understand and we can make an informed decision that whatever equipment that we have is as per the specification and it will work as it is conceptualized during the design stage of this equipment. Okay. So to do all of these things, obviously now if you are working towards your ICP examinations, either it is going to be 570, 653 or 510. In all of those areas, those codes are generally in-service inspection codes, and also these codes are going to be used for repair, re-rating, in some cases reconstruction also. In that case, if you are doing repairs, if you are doing re-ratings, that means sometimes you will have to buy some material. Let's imagine if your bolt is severely rusted. In that case, you will need to buy a new bolt. In some cases, your spools are having a thickness that is reaching to a point where it is going to reach its lowest thickness that is desirable. In that case, you might need to change that pipe spool to a thicker section. In that case, when you are buying this replaceable items, or when you are buying some extra material for your repair scenario, in that case, we have to make sure that whatever the material that we are installing here is as per the requirements, it is as per the process conditions, and it is as per the specifications that were given. Secondly, we would also need to understand the welding that we are going to do. Now welding will generally be done, if it's a manual welding, if it's a shielded metal arc welding, you'll have generally electrodes. In that case, some verification of that electrode also needs to be done, because if your electrodes composition is not as per the requirement, then your weld is not going to behave for what situation it was designed for. So if it was designed for 700 kilonewtons, it might not go on for 700 kilonewtons. If your electrode was selected in some cases that you require a corrosion resistance, you have 5% nickel there. But if you're not using that electrode, then it will be subjected to corrosion and it would be useless. Okay. So to eliminate all of these things, during repair and maintenance operation, every ICP codes, that is 570, 510 and 653, will recommend that an owner and user should have a material verification program for new as well as for existing equipments. New equipment, it's a good practice, always you need to have everything for the new equipment, but if you have equipment that is working for a very long time, you might also try to do some retroactive material verification, so that you at least you understand what are the risks involved there. So again, these are forwards, the initial part of the document. Now this document is very short, it's like 13-14 pages only. Very general informations are given here. You can again read it once, it's very self-explanatory, but then again 2 or 3 sections of this code are more important than others. Just we'll talk about this when we go there. So first, already we know this, that first section is always going to be scope. The scope, the purpose of this code is, the purpose of this recommended practice is to provide guidelines for owner user to develop and implement a material verification program as a part of asset integrity program. So it is the responsibility of the owner or user to develop a material verification program as recommended by 578 for their asset integrity programs. About this document, this is a recommended practice that provides the guidelines for material verification program involving ferrous, non-ferrous alloys during the construction, installation, maintenance and inspection of new and existing process equipment. Again, supersedes notice, that means the earlier version of this recommended practice was now been superseded by this version. Next is terms and definition. Again, the terms and definition, just read it once, self-explanatory. Again, most of the things you would already know here, but again, at least once read is good. Okay, sometimes you need to understand what are some definitions. Most of the things you'll understand, some things you'll not understand, you just remember them. Next is consideration and concerns. So these are some concerns that can happen if the material verification program was not properly implemented. There are some scenarios that can go on where your material might be subjected to accelerated amount of damage, which could lead to severe loss of life, as well as also you will have economic problems if some accident happens. So consideration and general concerns. So carbon steel substitution in a low alloy steel systems. When considering the likelihood of material non-conformances, it is worth noting that historically the greatest number of material non-conformances with serious consequences have been involved in placing unapproved carbon steel components into low alloy steels of piping system. So substitution, in most cases when you substitute low carbon to when you substitute carbon steel to low alloy steels, most of the scenarios, most of the damage has happened. So a proper analysis needs to be done, that is the substitution is going to have any adverse effect or not. And then obviously if you have scientific judgment here, if you have verification that this is not going to cause some problem, then this can be done. Now, when determining the need to perform the material verification on carbon steel, the owner user should evaluate the effect that the process stream could have on the substituted materials. In some cases, the substitution of a hardenable alloy materials for carbon steel has resulted in failure and loss of containment. Examples of such systems include those handling wet hydrogen sulfide, hydrofluoric acid and sulfuric acid. Stainless steel and non-ferrous substitutions. So stainless steel, again, stainless steel is substituted for some other kinds of steel, or non-ferrous material is substituted for some other non-ferrous materials, and in that case it might be subjected to some kind of problems as well. So there is an assortment of stainless steel with varying composition and varying corrosion resistance to different process steam. PMI should be considered by the owner user depending upon the level of risk Risk, obviously we know this, the risk is combined effect of probability of failure as well as consequence of failure. Based upon the potential damage mechanism and damage rates associated with the installation of unapproved high alloy during fabrication and installation. Examples of the situation and substitution of stainless steel for alloy 400 is hydrofluoride alkylation services, substitution of non-stabilized grade of stainless steel for a stabilized grade of stainless steel at high temperature services, substitution of type 304SS to 316SS, where molybdenum content is important for corrosion resistance. So this can happen, multiple types of stainless steels are available, and if you substitute either of these, then some consequence will be there. Now again, some other things are also given here. You can just read them, not as important, but these are the section 4 of this is just establishing why you need to have a good material verification program. What can happen? You might feel that stainless steel is stainless steel, but again we have to consider the stainless steel has multiple grades associated with it. You have some stainless steel that have molybdenum there, some stainless steel will have phosphorus, some will have nickel, some will have more amount of chromium, less amount of chromium, multiple things are there, and according to what is the service condition, what is the process requirement, you'll have to select it such that whatever material you select should not degrade or should have an adverse effect by the process that it is handling. Okay, so that's it for this video. In this video we have seen what is a material verification program, what is the introductory part of API 578. We have also started and gone up to section 4, which is just general information. In the next video we'll be talking about section 5. Section 5 will talk about what is a material verification program, what are some requirements there. But that's it for this video. We'll meet in the next video. We'll go ahead with the section 5 of API 578. Thank you.